Hello class 10. In this video I'm going to cover up the MCQ of chapter 2. Now let us begin with exercise 2.1. Here the first question is if the figure shows that the graph of fx is equal to ax square plus bx plus c, then okay, these are the four given options. Now this is a quadratic polynomial here, ax square plus bx plus c. Now we know that the graph of a quadratic polynomial is a parabola. So here the parabola of this quadratic polynomial is this one. So this is what is given in the question. Now since the parabola is cutting, since the graph is cutting the x-axis at 2 points, here like this, here and here, it shows that there are two zeros of this polynomial, and these 2 points lies to the right of this origin. That means on the positive x-axis. So the zeros of this polynomial, both the zeros are positive, plus. So we can take an example of 2 and 3. Now we know that for forming the quadratic polynomial we have a formula like this: x square minus sum of the zeros, x plus product of the zeros. Now if we use this 2 and 3, then sum 2 plus 3 is 5, x plus product will be 2 into 3 is 6. Now this is the quadratic polynomial which we will get if the zeros are 2 and 3. Now if we compare this with the standard form, this ax square plus bx plus c, then we get here a equal to 1 and b equal to minus 5 and c is equal to 6. So this means a is greater than 0 since this is positive, and b is less than 0 since this is negative, and c again is greater than 0 because this is positive. So this is our answer. Now let us check this here: a greater than 0, a greater than 0, b less than 0. So this must be our correct answer. But here we can see that it has given c less than 0, but our answer is c greater than 0. So this must be the correct answer. This must be printing mistake. So here we write it here, greater than 0. Now let's move on to the next question. Okay, question number 2. Okay, the graph of y equal to px is given. The number of zeros of px are, okay, we have to observe this graph and we have to give the answer. Now when we observe this, what we got is this curve, this graph is cutting the x-axis at exactly 2 points, here 1 and another here. So which means that there are two zeros of this px, polynomial px. So the correct answer is this one. Okay, so our answer is Roman number 3 and this is 2. Okay, now question number 3. Okay, which of the following is a polynomial? Okay, we have to remember that the power in a polynomial is a whole number. So that means it cannot be negative number, it cannot be a fraction. So let us see this first one. Now this is 2x squared plus 1 by x. So in another form we can write 1 by 2x squared plus x to the power minus 1. So since x is in the denominator, so we have power here minus 1. So this is not a polynomial because the power is not a whole number since it is minus 1. And Roman number 2, minus 3x squared plus 6 root x, again root x. So in another form we can write like this: root, it simply means the power is 1 by 2. So again the power here is fraction, so this is also not a polynomial. And then the third one, root 2x cubed plus root 3x squared plus x minus 3. Okay, here the power of x is 3, here 2, here 1. So the power, all these are whole number, so this must be our correct answer. Here the fourth one, x cubed is in the denominator, so obviously this is not a polynomial, because if we write in this form we will get minus 3 in the power. So the correct answer is root 3. Now we are moving on to the next exercise, exercise 2.2. Okay, the first question is zeros of px is equal to x squared minus 2x minus 3 are, okay, so these are the given option. So this one you can find out the answer in two ways. I'll show you both the ways. Okay, firstly you can check by substituting this 1 and minus 3 one by one. So, and if you're getting 0 in both the cases, then you'll say that these are the two zeros. Okay, so we will try with 1. So this is our polynomial here. This is a quadratic polynomial. Now if I substitute in place of x with 1, then 1, you'll get 1 square minus 2 into 1 minus 3. Now this one square is 1, and here minus this is 2 minus 3, so here we get 1 minus 5. This is minus 4, which is not equal to 0, so this answer is rejected. And next this one, now let's try putting minus 1. So you will get here minus 1 square minus 2 into minus 1 minus 3. Now this one is minus 1 square is 1, minus minus plus 2 ones are 2, minus 3, so we get here 3 minus 3 equal to 0. Okay, so this one is a 0 of this polynomial, and next we will check minus 3. Okay, so in place of x we're going to substitute minus 3 again. So minus 3 square minus 2 into minus 3 minus 3. So here we get 9, minus minus is plus, 2 3s are 6, minus 3. Now this is 15 minus 3, this is 12, which is not equal to 0. So again, because of this minus 3, this is rejected. So it has to be minus 1 and 3. It has to be minus 1 and 3. 1 is rejected, 1 is not the zeros. So if we try with 3, we will surely get 0. You can see here 3 square minus 2 into 3 minus 3. Now this gives us 9 minus 6 minus 3. Now we have here 9 minus 9, this is equal to 0. So minus 1 3 is the answer. Now we're moving into next question, question number 2. Okay, if the sum of the zeros of the polynomial fx is equal to x cubed minus 3kx squared plus 4x minus 5 is 6, then the value of k is, okay, this is a cubic polynomial, and here a is 2, b is minus 3k, c is 4, d is minus 5. Now we know that sum of the polynomial is let's just say sum of the polynomial, sum is minus b by a. Even though this is a cubic polynomial, the formula remains the same. Now we have here sum. The question says if the sum of the zeros of this polynomial is 6. So sum here is 6 is equal to minus b. b is this minus 3k. So b is minus 3k by a is 2. Now this gives us 6 is equal to minus is plus, so we get here 3k by 2. Now if we cross multiply this, then you will get here 3k is equal to 2 6 or 12. Now dividing both sides by 3, we get here 12 by 3, so we get here 4. So 4 is the value of k. So option number 3 is the correct answer. Now we're moving on to the next question. Here it says, if alpha and beta are the zeros of the polynomial fx is equal to px squared minus 2x plus 3p, and alpha plus beta is equal to alpha beta, then the value of p is. Okay, now look at this given condition. Here alpha plus beta is equal to alpha into beta. Now alpha plus beta is nothing but sum of the zeros, and alpha into beta, that means this is product of the zeros. So what it says here is sum of the zeros is equal to the product of the zeros. So we're going to use the same formula. Sum of the zeros, alpha plus beta, is minus b by a, and product of the zeros is alpha into beta, and this is c by a. Now since the question has given us alpha plus beta is equal to alpha into beta, now if we substitute these two values here, minus b by a will be equal to c by a. This is sum of the zeros, and this is product of the zeros. Now we cancel out this a. Now what we got here is minus b equal to c. Now this, if the sum of squares of zeros of the quadratic polynomial 3x squared plus 5x plus k is minus 2 by 3, then the value of k is, okay, here sum of the squares of the zeros of the quadratic polynomial is minus 2 by 3. So let us suppose that the two zeros are alpha and beta. Let us suppose that the two zeros of this quadratic polynomial be alpha and beta, and according to this question, sum of squares of zeros, so that means alpha square plus beta square of this polynomial is minus 2 by 3. So this is minus 2 by 3. Now before we go further, let me show you this one. A plus b holding square is equal to a square plus twice ab plus b square, as you know this formula. Now if we transpose this to the twice ab to the left hand side, then we will get here holding square minus this plus changes to minus twice ab is equal to a square plus b square. So what we got here is a new formula. So a square plus b square is a plus b holding square minus twice ab, or in this way we can write a square plus b square is equal to a plus b holding square minus twice ab. Now we're going to apply this formula here. Alpha square plus beta square, this one we can write alpha plus beta holding square minus twice alpha beta is equal to minus 2 by 3. Now in this polynomial, if we compare with the standard form ax square plus bx plus c, then what we got here is a is equal to 3, b equal to 5, and c is equal to k. Now, and also we know that sum of the zeros, that means alpha plus beta is equal to minus b by a. So minus b is 5, a is 3, and product of the zeros, that means alpha into beta, is c by a. So this is c is k, a is again 3. So Now what we're going to do is we're going to substitute this value here. So alpha plus beta is minus 5 by 3. So minus 5 by 3 minus 2 alpha beta is k by 3 into k by 3. Now this is minus 2 by 3. Now what we got here is minus 5 folding square is plus 25 and 3 square is 9 minus 2k by 3 is equal to minus 2 by 3. Now we're going to take LCM. So LCM of 9 and 3 is 9. We get here 25 minus 3 is a 9, 3 2 is a 6, 6k is equal to minus 2 by 3. Now we can cut here, 3 1 is a 3, 3 3 is a 9, and after this we're going to cross multiply. So 25 minus 6k is equal to 3 2 is a 6. Now this will give us minus 6k is equal to minus 6. Now we will transpose this minus 25 to the right hand side, so plus become minus 25. And next step, minus 6k is equal to this one, we get here minus 31. So we can cancel out this minus minus, so we got here k equal to 31. Six here, so we got here k is equal to 31 by 6. So 31 by 6 is our answer. Now let us check the option. Okay, the first one is Roman number 1, 31 by 6. So this is our answer. Now we're moving on to the next question, that is question number 6. Okay, the sum and product of zeros of polynomials are this and this. Polynomial x squared minus 4x plus 3 are this and this, this and this, this and this, this. So we're going to choose the correct answer from these four options. So now this is a very simple question. We know that sum of the zeros is minus b by a, and product of the zeros is c by a. C by a. Now this quadratic polynomial, if we compare with ax squared plus bx plus c, we got here a equal to 1, b equal to minus 4, and c is equal to 3. So now let's substitute here. Minus b is minus 4, a is 1, so minus minus is plus, so 4 by 1 is 4, and product of the zero is c by a. C is 3, 1, a is 1, so we get here 3. So the sum of the zeros is 4 and the product of the zeros is 3. So our answer should be Roman number 2. Now this is the end of exercise 2.2. Now let's move on to the next exercise, that is exercise 2.3. Okay, the first question is the polynomial which when divided by this gives a quotient x minus 2 and remainder 3. Now we're going to see which one should be the polynomial from this 4 given option. So we know that dividend is equal to quotient into divisor plus remainder is equal to dividend. So this is dividend. So our polynomial is going to be quotient is x minus 2 into divisor is minus x square plus x minus 1 and plus remainder is 3. Now let's multiply this. X will multiply all this, again minus 2 will multiply all this, so x into minus x square is minus x cube, again x into x is x square, again x into minus 1 is minus x. Now with minus 2 into minus x square is minus is plus 2x square, and minus 2 into x, so minus 2 into x is minus 2x. Again minus 2 into minus 1 is plus 2, minus is plus, so we have here 3. Now let's see the like term here, x square and 2x square, so both these are plus, so we get here 3x square, and then minus x, minus x minus 2x, so minus 3x plus 5. So this is our polynomial. Now let's see which option gives us this one. X square, x cube, this is x cube, x minus x cube plus 3x square minus 3x plus 5. Okay, so this Roman number 2 is the right answer. Now let's move to next question, question number 2. Okay, for what value of k is the polynomial px is equal to 2x cube minus kx square plus 5x plus 9 exactly divisible by x plus 2. Okay, now let us recall what we learned in class 9 also. Now the given polynomial is 2x cube minus 5x kx square plus 5x plus 9. Now this is a given polynomial. Now if this polynomial is to be exactly divisible by x plus 2, then the remainder should be 0. Now if we say this is equal to 0, then we get here x is equal to minus 2. So okay, so p minus 2 equal to 2 into x is minus 2 cube minus k into minus 2 here x square, so minus 2 square plus 5 into minus 2 plus 9. Now this gives us minus 2 cube is minus 8 into 2 is minus 16. Here minus 2 square is 4, so 4k plus minus is minus again, 5 to the 10 plus 9. Now this gives us minus 16 minus 26 plus 9 is 17. So you have here minus 17 minus 4k. Now since this polynomial is exactly divisible by x plus 2, this remainder must be 0. That means p minus 2 must be equal to 0. So p minus 2 is this one, minus 17 minus 4k is equal to 0. Now let's transpose this 17 to the minus 17 to the left hand side. So we get here 4 minus 4k is equal to 17. Now this gives us 17 by 4. So our right answer is minus 17 by 4. So option number 2.